Okay, okay. Hi, hi, hi. Hi. Yeah. Right. So, hello, sir. Hi, hi, hi. Hi, everyone. Hi, sir. So, I think people got very good lunch, quite relaxed at home. It's really scorching heat outside. It's better to sit back at home, relax, and study rather than doing some activities outside. I'm good, good. I'm good. I'm good. I'm fine. I'm fine. I hope all of you are as bright as butter. Yeah. Yeah. First, before beginning, a slight apology from my side. I may sound a little bit dull today. I was going through viral infection. My chest is badly infected. I'm just recovering. So please cooperate. I'll try to grasp as much energy as possible in due course of time. We'll slowly pick up. Right? Yeah. Yeah. Okay, so how is the feeling after 10th? I think 3 weeks class is already done. You had some basic mathematics classes in physics, some elementary knowledge you have, and then this is the 4th week that you are transiting into. And shortly after, you will be onboarded into the campuses. So all chaps, all boys who are coming to Gosalites will be directly under me in track 1. Yeah? Yeah. Yeah. Fine. Done? I hope it's clear now. Right? Yeah. Fine. Yeah. Okay. So good to go. Good to go. Yes. So I was talking that this week we will be carry forwarding the topic that is called scalars and vectors. Very, very important. Extremely important. Predominantly, it seems to be mathematical, but it has great physical significance. It's a building block. So if you need to understand every bit of physics, class 11th and 12th, all I can say, if you're fluent in vector, if you're fluent in scalars and vectors, knowing all the concept as it in crude form, then you will be okay with almost 40% of the syllabus. Yeah, though I mean 40% of the total chapters in class 11th and 12th you can understand only through vectors. If you are okay with vector, you are okay with the 40% of the syllabus without knowing or without gathering any more knowledge. So this is very important. Please do listen. Please do listen carefully. And yes, right. So let's start. So first we'll do a story building. I mean, we'll get to know how the history proceed. Not coming to this magnitude direction part as of now. Please do remember when you are studying physics or mathematics, it's a very elegant subject, extremely elegant subject. So study those subjects the way that the flavors is often coming. I do remember from my school days, most of the people who fear mathematics is not because mathematics is scary, is because the people who taught mathematics are scary. In my school, I remember all my teachers used to have different sets of curves over their foreheads. They used to come in the class with radius eyes and parabolas and hyperbolas over their forehead. So before asking a question, we get terrified. So the idea, the notion was if someone is going to teach mathematics, it must be crazy, it must be very tough, but it's not like that. So let us do. See, scalars and vectors, the basic idea, scalars and vectors, first came around 1830. We are sitting in 2026. The first idea of scalars and vectors came back in 1830. And I'm talking about the time, 1830s, 1840s, where we did not have Instagram, most importantly, right? Yeah. So 1830s, 1840s, we did not have Instagram. We did not have multiple account, by the way. Instagram nahi tha to multiple account kahan se aayega? Why? So we were not having Instagram. We were not having any social media platform. What I'm trying to tell you is that there was no communication, absolutely no communication possible between two people sitting in two different places in two different countries. So 1830s first idea came. It was by a German scientist called Henman Grassmann. Then 1840, a Swedish person gave another idea. Around 1843, William Gibbs and Huysman, these are the two persons who first gave the vector algebra, right? 1843. See the time frame. Then 1880, 1830 started, 1843 something came. Then 1880, final mathematics is coming. How many years? 50 years, right? And what we do? We try one question for 5 minutes. If it is not coming, short answer is not coming. You know how difficult it is. I can't explain. Patience is the key. So in scientific domain, patience plays a very important role. We have to be patient with whatever you are doing, whatever you are learning, right? So we have to be extremely patient in our learning journey. If learning journey is fantastic, then learning outcome will also be excellent, correct? So 1880, mathematics came. 1903, finally some crude form of mathematics came into the world, which could briefly describe mathematically how the vector operates, where they are applicable, what is the condition in which they operate, and all these things. I'm not going to those technicalities. Yeah. See, right. So now the point is, a subject, a thing, a branch, which took almost 50 years in the pre-development phase. How many days we will study? 5 days. 50 years development in 5 days. So we are smart learner, right? All of you, you are smart people. 50 years of knowledge we'll try to gather in 5 days. We must be smart people. You are smart people, no doubt about that. You are. One second. Yeah. So, yeah, you are smart people. By the way, what you are, Gen X or Gen Millennial? I mean, I get confused in that. You are Gen X people, right? Gen X or Gen Millennial? Kuch bhi ho. Gen Alpha, oh, come on. Yeah. Correct. Fine. Gen Alpha. I have all these terminologies. I have abbreviated form of Gen Z, Gen Alpha. When you come to the class, then I will be able to say, because in public platform, I can't say. I'll tell you, I'll explain you what Gen Alpha and Gen Z. Abhi nahi batayenge, class mein bolenge. Yeah, there is something which needs to be private in the family. Yeah, okay. So, talking about the quantities which are scalars and vectors, right? Two quantities we are talking about. Which quantities? We are talking about scalars and vectors. Please pay attention. We will learn interesting things, and I need your cooperation. Yeah. So first thing we are going to study about this quantity, which is called scalar. Well, scalar quantities are the quantities which has magnitude only. Scalar quantities are the quantities which has magnitude only, no specific direction. Correct? Is that idea clear? So two important words I have uttered. One I have said that they have magnitudes only, and I have said they do not have any specific direction. Netra is saying no direction. No, Netra, I did say no specific direction. I just added one word, specific direction, right? Yeah. So scalars, these quantities, they have magnitude, but no specific direction. So scalar quantities are quantities. Write something big. Okay, ma'am, I'll try, Harshita, ma'am. We'll get to see in due course of time. The letters will keep on increasing, right? Yeah. By the way, if you're watching in phone, ma'am, can you put the phone on the landscape mode? Don't watch it upright. Put it on the landscape so that the aspect ratio is 16:9. Huh? I have to tease the aspect ratio to Gen Z? Oh, come on. Okay. Fine. So have magnitude but no specific direction. Okay. Have magnitude but no specific direction. Example, mass, और क्या दे सकते हैं? Volume or speed, work done, energy. We can keep on giving. Distance, yeah, distance. Few more. Pressure. Okay. Good. Few more. Speed, yeah, speed, good. Few more. Time, okay, right? No, velocity is not a scalar quantity. Electric current, yes, it is. It is. It is debatable. I will explain about that also. Yeah, yeah. Okay, okay. Good, good. Very good. Power, yes, power. Power is also a scalar quantity. See, you all have the basic knowledge. You are good fellows. You are very good fellows. Yeah, yeah. Love you all. Very good fellows you are. Chalo. Next quantity I am going to describe is they are vectors. Vectors, right? Potential difference. Oh, so heavy terms. Yeah, it is. It is. It is also. Right. Yeah. Vectors. What about vectors? These quantities have magnitude as well as specific direction. These quantities have magnitude as well as specific direction. See, again and again I am putting stress on this word. Can you please see? I am putting stress on this word. Specific direction. It is very important. Direction तो कुछ भी हो सकता है, random भी हो सकता है, random नहीं होना चाहिए. The direction has to be very much specific. Got it now? Yeah. सर विल यू बी टीचिंग डॉट प्रोडक्ट? अरे यार तू यार ब्रेकफास्ट कर ले पहले, बिरयानी के बारे में तो लंच में सोचेंगे ना, पहले ब्रेकफास्ट कर ले भाई. ओके, सो दे हैव मैग्नीट्यूड्स as well as specific directions, right? So these quantities are called vector quantities. Yeah. Example please. Both YouTube as well as Zoom, all listeners, spam it, spam the box with vector quantities. As many vector quantities you know. Yes, displacement, velocity, very good. Some more. Force, yes, very good. Here, YouTube, Zoom people are answering more. YouTube, please. Tension, weight, great. Momentum, very good. Very good. Acceleration, displacement velocity, torque, yeah, fantastic. So good. Yes. Yes. Yes, 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 yes. Good. I got quite decent answers. So I got the answers as displacement, then force, velocity, acceleration, displacement, force, velocity, acceleration. Someone said momentum, very good. Even torque also. Just now I got one, electric field. Wonderful. So impressed. Yes, very good, very good. Very, very good. So nice of you. So nice of you. Very nice examples given. Yeah. Yes, yes, yes. Magnetic field. Yeah, magnetic field is also a vector quantity. True. 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 Yes, yes. Very good. Very, very good. Chalo. Correct. So these are the quantities, right? Okay. Fine. So now, see. So I have discussed about scalars. I have said about vectors. Then what is the difference between them? We have categorically said that scalars are the quantities which have magnitude but no specific direction. These are the examples. And then we have taken the examples of vectors. They have magnitude as well as specific direction. And then pressure also, na sir, no beta, pressure is not. Pressure is a very unique kind of quantity which I will explain shortly. Just now, abhi batayenge. Okay. Yeah. So other than these two quantities, sir, can we distinguish all the physical quantities only under two umbrellas, scalars and vectors? Well, the answer is no. There is another type of thing which is the bigger umbrella. So please understand, there is a bigger umbrella. Scalars and vectors are just a normal representation. Normal representation. There is a bigger umbrella. What is a bigger umbrella? Well, before saying that, let me tell you very categorically, the thing that I am going to tell you right now, I will restrict my discussion up to a certain extent because that is grossly mathematical. It is little bit clumsy and complex. So we will keep it very intact, short and crisp. As much is required, I will tell. Beyond that, no how, why. Is it okay? Agreed? Right? Okay. That quantity is called, beta, all my dear friends, they are called tensor. What they are? They are called tensor. What I told, tensor is a bigger umbrella. Tensor is a bigger umbrella. You can imagine that tensor is actually an apartment, the block of an apartment. Under the block of an apartment, there are 2-3 flats, and let's consider the scalars, the vector, they are flats. And the bigger apartment is which one? Is the block. That is tensor. So the question is, sir, is scalar a tensor? Yes, it is. Is vector a tensor? Yes, it is a tensor. So now I am saying what? Two information I am giving. Scalar. Is it a tensor? Yes, it's a tensor. Scalar quantity is a tensor quantity. Clear? Sir, is vector a tensor? Yes, vector is also a tensor. Correct? So scalar is a tensor, vector is also a tensor. Sir, is there any difference between them when we call them tensor? Yes, there is a difference. Only information I am giving. No how, why, but because if I do the mathematics, people will be senseless. So yeah. What is that? This is called tensor. Tensor of rank 0. So what are the scalars? What are the scalars? Scalars are tensors of rank 0. Scalars are tensors of rank 0. What are the vectors? Vectors are tensor of rank 1. Vectors are tensor of rank 1. Correct? Fine. So I have categorically said few information. What I am telling now, please listen to me. Tensor is a bigger umbrella. Both scalars and vectors are tensor. Correct? What is a tensor? Tensor is particularly that thing which gives more information about a physical quantity than scalars and vectors. To give you a lump sum idea, let us imagine that someone's address. Suppose you are going to give our address. Either I can say that I live in that particular apartment, in that particular floor, in that particular flat number. Is that clear? So what I'm saying, I live in that apartment, that particular floor, and that flat. Let's say I stay in an apartment, that apartment name is X. I stay in the first floor, my flat number is E108. So I stay in X apartment in the first floor, flat number E108. So how many informations are there? 3. 3 information. Now, can you scale it up? Can you scale it up? Yes, I can. What you can scale it? You can say, sir, I live in a country called India. In that particular country, there is a state called Andhra. In that Andhra, there is a city called Vijayawada. In that Vijayawada city, there is a district called Krishna. In that district called Krishna, there is a post office called Poranki. Under that post office, there is one particular lane. In that lane, there is an apartment. There is a floor and there is a flat. So, am I giving more information about the address? Am I getting more information about the address? Correct? That's a tensor. When you are revealing more information and extracting more information, it becomes a tensor, right? So yeah, just information. Again and again, I am telling those who are asking, see, when you are studying physics, this is very important. Please listen to me. When you are asking why, please be very, very careful, because it is very important to know why you are asking why. Don't ask why without knowing why you are asking why. So please be careful. Yeah. So scalars. What are the scalars? I have given this much enough. Tensor of rank 0, vector, tensor of rank 1. I had no intention of giving this, but I know you people are very excited people. You have infinite amount of energy. You search this book, that book. Suddenly you come up with the word called tensor. You'll gag my head once you come to the campus. So that's why I'm giving you pre-information. This is a tensor, right? What is an example? What is an example, sir? What is an example, sir? Example is this one, sir. This one is the example, sir. Finest example. This is the example, sir. Electric current is the example. Electric current is the example. Yes, electric current. It is a tensor. So if the question comes, now listen to me. If the question comes, is electric current a scalar quantity? Yes, it is. Thumbs up, everyone. Electric current, is it a scalar quantity? Is it a scalar quantity? Yes, it is. Correct? Is it a tensor quantity? Yes, it is. So then, what is the correct information? It's a tensor of rank 0. It's a tensor of rank 0. Correct? Don't worry, it is never going to come in the exam. It's just for your satisfaction. Something you read? Pressure, very good question someone asked. See, you are beautiful people. You are very good student. Although you are studying NEET, but you have huge appetite for the knowledge. Someone asked me, what is pressure? What is pressure, sir? What is pressure, sir? Pressure is a tensor of rank 2. Pressure is a tensor of rank 2. Correct? See, I will not extend this discussion. This will be too much mathematical, so let us restrict over here. We will not go beyond this. So electric current, is it a tensor? Yes, it's a tensor. Is it a scalar? Yes, it's a scalar. What kind of scalar? It's a tensor of rank 0. Pressure, is it a vector quantity? No, it's not a vector quantity. Is it a tensor quantity? Yes, it is. What kind of tensor? Tensor of rank 2. Correct? Yes, very good. Now, I will give you a very nice, simple explanation why essentially tensors are not vectors. Simple, within our limit only. We can understand very carefully. No problem in that. All of you, all my dear friends, please look at the board. Please look at the board. Class 10th level discussion only I will do. So let us say, boys and girls, through this branch, I have a current I1 is equal to 3 ampere. Through this branch, I have a current I2 is equal to 2 ampere. Okay, na? Yeah. Sir, how will you give ranks? Please, no more knowledge. We will not go beyond that. Let us restrict here. Let us restrict here. You are not following me. You are not following my language. I am a man of words. So please follow my language, what I am saying. So there is a current coming in, 3 ampere. There is a current coming in that is equal to 2 ampere, right? 3 ampere and 2 ampere coming, correct? So what is the current going here, beta? 3 plus 2, that is equal to how much? 5 ampere. Easy to understand, everyone? Very easy to understand. Very easy to understand, right? Yeah, 5 ampere. Yes, 5 ampere. Correct. Very good, very good. So nice of you. I draw one more diagram. Let's see who can answer. Everyone can answer. I have full faith in you. You are good students, very good students. Tell me, I have current I1 is equal to 4 ampere. I have current here I2 is equal to 1 ampere. So what about current I3? Come on, boys and girls, all my dear friends. All my dear friends. Look at the direction. Look at the direction. Look at the direction of the arrow. 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 I think almost all the people got it wrong. Whatever answer I am saying here. Yeah, here few correct answer is coming. Very good. 3 ampere, 3 ampere, 3 ampere. Fantastic. 3 ampere. Yes, 3 ampere. Absolutely correct. 4 ampere coming in. 4 ampere coming in. 1 ampere going out. So how much will pass through this? That is 4 minus 1. That is equal to 3 ampere. Okay, Ray? Clear now? Clear now? Fine. 3 ampere coming in. 2 ampere coming in. 3 plus 2, 5 ampere coming out. Is that clear? 4 ampere coming in, 1 ampere going out. So 4 minus 1, 3 ampere going out. Is that clear? Correct? Correct. Please respond. Easily. So did you see one thing? That total current, we are doing simple scalar addition. Total current, we are doing simple scalar addition only. है ना? We are just adding the magnitudes or subtracting the magnitudes. Just adding the magnitude and subtracting the magnitude. That's it. Very simple. Right? Correct? But if there is a force F1 is equal to 4 Newton. Let us take 3 Newton only. And there is another force F2 is equal to 2 Newton. Can we say that this force is equal to 5 Newton? Absolutely not. Absolutely not. Now understand the difference. I could write this for the current. I could write this for the current. Can I write it for the force? When I am writing for current, it was quite okay. But when I am coming to force, is this allowed? No, it's not allowed. It's not allowed. Yeah. Yes. Yeah. Understood now? What is the difference? You got the clarity regarding the difference? So this operation I can carry out for the current. But can I carry out this operation for this force? No, I can't. So that is why, beta, this one is a tensor, which is basically a scalar of, this is also a scalar. It's a tensor of rank 0. And this one is a vector quantity. Correct? How to find the force? I will come. Definitely we will discuss. It will take some time. But now I am just telling you the difference. How a tensor quantity is different to that of the normal scalar or vector quantities. ठीक है? मैं एक बार quickly revise करता हूँ. सब सुनिए, ध्यान से सुनिए. एक बार फिर से रिपीट कर देते हैं. चलिए जल्दी, फटाफट एक बार रिवीजन. Scalar quantities, they have magnitude, no specific direction. Lot of examples we have given. Vector quantities, they have magnitude as well as specific direction. So many examples I have given. Then what I have said, scalars and vectors both come under a common umbrella, a bigger set. What is that quantity? That is called tensor. So a tensor can explain a scalar, a tensor can explain also a vector. Correct? Okay. I have given some example. I have said just information, no clarification regarding this in terms of mathematics. That is very clumsy. So here, scalars are basically tensor of rank 0, vector are tensor of rank 1. Example, electric current, pressure is also a tensor quantity. Correct? Okay. I have given one example over here, how the tensors are operationally different from vectors. In which way they are different? When you are adding to electric current, you simply add their magnitude, you get the total current. Can you do it for the vectors? No, we can't. How to identify either scalar or vector when unknown quantity came? We'll gradually understand. Please wait. Direction, magnitude, it will slowly play. Okay? Fine. Chalo, let's go ahead. So now let us stick to this quantity only. Whatever we have done till now. Yeah. So now we are settling down. Please settle down. Please settle down. Yeah. So now we will learn about vectors. Now we can level. Snehita, we can write vectors as tensor of rank 1. But let us restrict that. Each time, so much big sentence to write vectors of tensor of rank 1. It looks very clumsy. Plus that discussion is not that much important for the part of our study. So I'm dropping that idea as of now. Okay? Right. Yeah. Someone is asking when the college will open. Yeah, that's a very good question related to this topic. Yeah, that's a very good, nice conceptual question asked. Yeah, anyway, so vector. Question is representation of a vector. What is the most important thing? The most important thing is the representation of a vector. Representation. Please, chalo. So first thing is representation. How do we represent a vector? Yeah. How do we represent a vector? Okay. How do we represent a vector? A vector, please note down, all of you, please note down. It is represented by an arrow. It is represented by an arrow. Please note down. It is represented by an arrow. Right? Yeah. Correct. In that, Note down, length of the arrow denotes the magnitude. Yeah. Slowly we'll explain everything. Length of the arrow denotes magnitude. Which chapter are you teaching, sir? I am teaching astrophysics, beta. This is scalars and vectors. Okay. Fine. Yeah. Fine. Yeah. Correct. So length of the arrow denotes magnitude. Next, tip of the arrow denotes direction. Fine. See here. Yes. So vector is represented by a arrow. We will represent a vector by an arrow. See, if I draw an arrow over here, please see. We represent a vector like this by an arrow. Correct? We represent the vector by an arrow. Correct? Fine. Okay. Where this length, this will give the magnitude. This will give the magnitude of a vector. This will give the magnitude of a vector. Very nice answer. Very good answer. Very good answer. And this tip over here, what this will represent? This will represent the direction. This will represent the direction. Yeah? Correct? Fine. Yeah. Good. So a vector is represented by what? A vector is represented by an arrow where the length of the arrow denotes magnitude and the tip of the arrow gives the direction. Length of the arrow denotes magnitude and tip of the arrow denotes direction. Okay? Okay. Yes. Very good. So now let us take few examples. Through examples, can a vector? No, at one time it is not possible. At one time it is not possible. We will come. It's a very good question that you have asked, but we will come to that explanation. Dekho. So let me take two examples. So these are the two vectors I have taken. Let us say this is one vector and this is another vector. Correct? And then I am taking one more vector. This is another vector. So let us say this is my example 1 and this is my example 2. So we have example 1 and then we have example 2. Correct? Yeah, fine. So look at this first example. So who will tell me? See, if I say this is vector 1 and this is vector 2, which has greater magnitude? Which one has greater magnitude? Quickly, which one has greater magnitude? Fast. Which one has greater magnitude? Very good response. So nice of you. Which one has better magnitude? Greater magnitude, which one? 1 or 2 in first example? Yeah. Correct. Yes. 2. Very good. So nice of you. So magnitude of 2 is greater. Magnitude of 2 is greater. Can we say, everyone please focus on the diagram. Can we say that 1 and 2 are in the same direction? I am putting my question once again. Can we say 1 and 2 are in the same direction? Can we say 1 and 2 are in the same direction? Can we say? Yeah, yes. Very good. So nice of you. So both vectors are in same direction. Both vectors are in same direction. Yes. That's a very prompt answer. So we have two vectors which are in the same direction. We have two vectors which are in the same direction but have different magnitude. So about 1 and 2, what can we say? 1 and 2 are in the same direction but have different magnitudes. Correct? All right. Done, everyone? Yes. Simple. They are very easy, very basic stuff, extremely basic stuff, right? Yeah. So note down, when these two things are there, we can say that these two vectors are parallel vectors. These two vectors are parallel vectors. So when can we say parallel vectors? When two vectors are in the same direction. When two vectors are in the same direction, they are called parallel vectors. Yes, very good. When two vectors are in the same direction, they are called parallel vectors. When two vectors are in the same direction, they are called parallel vectors. Yeah, correct? Fine. Well, we can have many more mathematics added to this. We can also say that the two vectors must be proceeding, or two vectors must be approaching or increasing or decreasing in such a rate that they are never going to intersect. Then they are also a parallel vector. Okay. What if they are on a same line? We'll come to the definition. We have collinear vectors. All those definitions I will come later, slowly. First class, let us learn the basic very easily, very comfortably. After that, we'll come out. Okay, so these are two parallel vectors. So boys, all my dear friends, what about these two then? What we can call these two vectors? Let us name them 3 and 4. What we can call them? Are they anti-parallel? Yes, they are. So these two vectors over here, they are anti-parallel. These two vectors over there are anti-parallel vectors. Okay, done. Someone was telling either in YouTube or in there. Somehow I missed out. Someone saying opposite vectors. No. Please, no opposite vector. Be very careful with the language. You are in a domain. You are in a scientific domain. In scientific domain, you have to be extremely accurate about what word you are using. So please be careful. I'll come to those examples. Now I am taking two more examples. Let's see the difference. This is one vector. This is one more vector. All right. I have just cloned them. 1, 2. I'm taking one more, another set. Yeah. This is 3 and 4. So what is common in all these four vectors? Quick answers. What is common? between 1, 2, 3, 4? What are common? What are common? 1, 2, 3, 4. Yes, I am getting the answer. 1, 2, 3, 4. What is common? What is common? Same magnitude, same magnitude, same magnitude. Extremely good. Very good. Yeah. 1 and 2. 1 and 2. They have same magnitude. They have same magnitude. And do they have same directions also? They have same magnitude, and do they have same direction also? Same direction also? They have same magnitude as well as same direction? Correct? So when two vectors are having same magnitude and same direction, then these two vectors are called equal vectors. They are called equal vectors. Correct? So now see, jugglery of the words. You will be trapped in the language, and there you have to be extremely careful of not doing or not committing any mistakes. Can we say, I want to answer no. Can we say two parallel vectors are always equal vectors? Can we say two parallel vectors as equal vectors? Can we say two parallel vectors as equal vectors? Can we say two parallel vectors always equal vectors? Very good answer. Answer is no. Two parallel vectors may or may not be equal vectors. Correct? When two parallel vectors are equal vectors? When two parallel vectors are equal vectors? In which condition? When two parallel vectors will be equal vectors? When they have same magnitude. When they have same magnitude. When they have same magnitude. Two parallel vectors, they have same magnitude. Then they will be called equal vectors. Correct? Very good. Solid learning. Clear idea? Right? Sir, they also have the same magnitude. 3 and 4. They also have same magnitude. They have same magnitude. Yeah. They have same magnitude. Right. But are they oppositely directed? Are they oppositely directed? They are anti-parallel. They are anti-parallel. But anti-parallel. But they are anti-parallel. They are anti-parallel. These two vectors, they are called opposite vectors. Two vectors, same magnitude but anti-parallel, they are called opposite vectors. Yes? Yes. Idea clear? So see, these are very basic stuff. These are very easy stuff. But if you are not careful in knowing their definition properly, you might be trapped. These are called easy questions. But in easy question also, you will be trapped. Suppose statement-based questions are coming. Equal vectors are parallel vectors. True or false? 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 Absolutely true. Equal vectors are parallel vectors. Equal vectors are parallel vectors. It is true. 100% true. Equal vectors are parallel vectors. Correct? Fine. Let us flip. Let us switch now. All parallel vectors are equal vectors. All parallel vectors are equal vectors. True or false? All parallel vectors are equal vectors. True or false? False. You got it? You got it? So this is totally a game of language. You have to read the question very carefully before answering it. Clarity आया? देखो कितना simple logic है. ठीक है ना? I will give you one nice example. Yeah? Yes. Correct? Fine. So how things happens, and not necessarily each time you have to make extravagant effort. You have to make huge effort. to make it very interesting, spicy, and then productive. You have to be extremely careful in doing these things. Again, I am saying two equal vectors. What is the condition? What is the condition the vectors will be equal? They must be in the same direction. They must have the same magnitude. So two equal vectors have to be parallel vectors. Two equal vectors have to be parallel vectors. But two parallel vectors, will they always be equal vector? No, they will not be. They will only be equal vector when they have the same magnitude. Right? Okay? Yes. Right. Now, same logic. Two opposite vectors, do they need to be anti-parallel? Two opposite vectors, do they need to be anti-parallel? Yes, they have to be. Two opposite vectors, do they need to be anti-parallel? Yes, they need to be. 100% they need to be anti-parallel. Correct? But two anti-parallel vectors, will they always be opposite vectors? Two anti-parallel vectors, will they always be opposite vectors? Two anti-parallel vectors, will they always be opposite vector? No. For two anti-parallel vector to call opposite vector, their magnitude needs to be same. Correct? Their magnitude need to be same. Please keep this in your mind. We will not deviate from here without having proper concept. Right? Okay. So which one is the key word? What is the common word between these two? This is the common word between these two. These two are the common word. So what is mandatory in both the cases? Magnitude need to be same. Someone is saying, can you please repeat? I can repeat, but please listen. I can repeat a number of times, but provided by the fact you are listening. What I'm saying, please listen. Two parallel vectors, when they can be called equal vectors. Two parallel vectors are called equal vectors when their magnitudes are same. Correct? So two equal vectors, they will always be parallel vectors because they are parallel to each other. But will all the parallel vector be equal vector? Are you take an example now? Why are you tensed? You take this example. Chalo le lo. You take these two examples. These two vectors, are they parallel vector? These two, are they parallel vector? Yes, they are parallel vectors. Correct. But are they equal vectors? No. Magnitude different. Simple idea. Right? Exactly in the same way. You take this vector and then you take this vector. Are they anti-parallel? Yes, they are anti-parallel. Are they opposite vector? No. Why not? Magnitude are not same. Okay. Now I need clear-cut response. Shall we move away from this slide now? Right? Enough information done? Correct? Ho gaya, bahut ho gaya. Not more than this. This is a very simple idea. I think you are brilliant. You can understand this easy topic very carefully. Yeah? Enough we have done? Yeah? Correct? Fine? Right. Very good. So nice of you. Yeah. Yes, sir. Thank you so much. Yeah. Fine. Enough for this day? No, 5 minutes more I have. Yeah, let us study. First of all, let me congratulate you all of you. Thank you so much. After lunch also, in this particular hot and humid environment, everybody is attending the class, listening to the lecture, participating, answering. Very good. I can see in YouTube chat also, many people are also participating. In fact, they are participating, they only know. But yeah, but activity is there. Everything is okay, no problem. Fine. I've just given the exam. After the exam, again attending the classes, maintaining attention for so many days. Hats off to you. Yeah, champ. Love you all. Yeah. Chalo. Next. Yeah. Correct. Yes. Correct. Correct. Sir, finish. Okay, sir. We'll do, sir. Yes. Sir. Chalo. Fine. Next, just last 5 minutes to go. We'll learn a very interesting concept. Very interesting concept. Very interesting concept. And then we'll pack off for today. Correct? Chalo. What is the concept? Dekho. Sir, everyone, please pay attention, sir. Sir, please. కొంచెం అటెన్షన్ కావాలి సార్. నిద్ర వస్తుందా? ఏమైందిరా? yes. Okay. Fine. Okay. Sir, write neatly. I am trying, sir. This is not a handwriting class, sir. It's a physics class. Please do listen. Pay attention. है ना? The time you are spending in writing that, write neatly. In that time, if you try to understand, you will understand the concept. ठीक है? Okay. Yes. चलो. So this is a vector, right? This is a vector. लिखो. What is the concept? Concept is a vector can be parallelly shifted without changing its identity. Sir, very important concept, sir. Extremely important concept. In many places we will apply this idea. Dwarga, fast ga. A vector can be parallelly shifted without changing its identity. We will explain. Don't worry. Yes. Sir, you are a nice singer. Arey yaar, tu faltu hai. You must be last year student only. Chal, put. Let us talk about the studies only. हाँ, वो सब के बारे में बात करेंगे. Yes. हाँ, sure. Why not? Yes. Absolutely. Correct. A vector can be parallelly shifted without changing its identity. चलो सीखते हैं. Let us learn. Boys and girls, all my dear friends, please see. So this is one vector. I am shifting the vector over here. So I have shifted this much distance. Right. Okay. Or, sir, what I will do? I can take here. Let's say here. Same magnitude, same direction. You see, all these three, same magnitude, same direction. Are they having that? Same direction. I'm just shifting parallelly. Look at my hand. This is one vector. Now I take the vector here. I take the vector here. Initially it was here at this position. Now the vector is here. So I've shifted it parallelly. Will the vector change or it will remain same? Same. Exactly same. If this is a vector, this is also a vector. Right? All right. This is a vector. Look at my hand very carefully. This is a vector. This one is a vector. Now this vector I am putting a little bit down. Like this. Still they are in the same direction. Having the same magnitude, right? Same direction, same magnitude, still they are the same vector. So that's why the concept is written. Look at this. A vector can be parallelly shifted. You cannot rotate. What you have to do? Parallelly shift. You can shift a vector parallelly without changing the identity. Sir, देखिए ना, everyone please see ना. Let us take one more example ना. See sir, this vector. See sir, this vector. See sir, this vector. Sir, see na. See all this example na. All this example na. Are they same vector? Are they same vector? Sir, here identity means direction. Here identity means direction and magnitude both. Here identity means direction and magnitude both. Look at this. Look at these four vectors. Do they have the same magnitude? Yes, they have. Do they have same direction? Yes, they have same direction. They have same magnitude. They have same direction. Same magnitude as well as same direction. So can we shift a vector parallelly? Can we shift a vector parallelly? Yes. Can we shift a vector parallelly? Yeah. Correct. Fine. Fine. Yes. Yes. Last minute. Last 1 minute. Last 1 minute. Sir, this is one vector. Let us say this is one vector. So this is called the tip of the vector. This is called the tail of the vector. Huh? Same magnitude. You look. If this is, let's say, 10 centimeter, this one is also 10 centimeter. This is also 10 centimeter. This is also 10 centimeter. No change in magnitude. Harshita, is it fine? Correct. Let us come to this. This vector. Yeah. Head and tail. Yes. Head and tail. Now see. Just last 30 seconds. Now I hold this. Everyone, please pay attention. Sab log, idhar dekho. I hold this vector. I hold this point. I am rotating this now. Are you agree? This is one vector. This is one vector. This is the tip. This is the tail. This is the tail and this is the tip. This is the tip and this is the tail. I am rotating this. Will it be same vector or different vector? Chat box. Chat box. This is the vector. Now I rotate this. It will be same vector or different vector? It will be same vector or different vector? Different vector because of direction changing. So now if it is rotated, so a vector rotated about its tail represents a different vector. A vector rotated about its tail represents a different vector. Clear? Concept clear? Time up. Time up. I will end the class. Can I get 5 seconds more, please? Yeah? Yes. So if this is the vector, I am rotating the vector. This is the vector. I am rotating the vector. Vector is changed now. Yeah? Correct? Correct? Now, rotating. Did it become opposite vector? Concept you have learned already. This was the vector. Now I have rotated full 180 degree. Has it become opposite vector now? Concept learned already. Opposite in direction, equal in magnitude. Opposite vector. One more 180 degree turn. Will it become the same vector? Yeah? Will it become the same vector? Yes. So, last two. Khatam. This is the end of the class. A vector rotated by 180 degree will represent opposite vector. Such a nice concept. A vector rotated by 360 degree will be same vector again. Wow. A vector rotated by 180 degree. Correct? It will represent opposite vector and a vector rotated by 360 degree will be the same vector or equal vector. Correct? Okay, that's all. That's all for today. So nice of you. Thank you so much. Thank you so much. Go and take some rest. Immediately next class is on the schedule. Yeah. Yes. Now it's spinning a little bit. Yeah. Bye, guys. Bye. Thank you so much. Thank you so much. Yes. Okay. It was so nice interacting you all. Thank you.